Hey guys, welcome to my educational class, Connors educational class, and today we're going to learn about science. I'm going to talk about electron structure. The Bohr atomic model best represents the behavior of electron in bonding. In Bohr model, electrons are represented as negatively charged particles that orbit the nucleus of the atom in specific orbit called primary energy level or shells. Each primary energy level is a prescribed distance from the nucleus. The first level, also called K shell, is closer to the nucleus and is designed as level 1. All the electrons in level 1 possesses a certain amount of energy. Electron level 2, also called the L shell, have a higher energy level than those in level 1. As you move away from the nucleus, each succeeding level contains electrons with a higher energy level than the electrons in the preceding level. The specific levels in an atom might be compared with the lungs of a ladder. A person can only move up the ladder by stepping from one lung to the next. He cannot stand in the space between the lungs. In a similar manner, an electron can only move up or down by jumping from one energy level to another. It cannot exist between energy levels. Not all electrons orbit the nucleus in circular orbits within each energy level. The electrons move in slightly different patterns or shapes. Some electrons orbit in circular patterns. Others move almost in the shape of a figure 8, and some revolve in much more complex orbits. Each of these patterns within a level is called the sublevels. Sublevels are indicated by the level letters S, P, D, F. There are other sublevels, but they are never considered in chemical reaction. Level 1 contains only one sublevel, which is designed as 1s. Level 2 contains two sublevels, designated as 2s and 2p. Level 3, also called M shell, contains three sublevels, 3s, 3p, and 3d. Each level contains one more sublevel than the previous level. An atom is a three-dimensional object with electrons flying around the nucleus at different levels and in different patterns. Imagine you are holding a small ball in one hand and a thin metal ring. Larger than the ball in the other, it is possible to place the ring around the ball in several different positions. You might hold the ring vertically, horizontally, or in several other positions between these two. You might be able to see the shape of the entire ring, or only one side of it. Any of these positions of the metal ring might represent the orbiter, or the paths of electrons around the nucleus of an atom. The diagram below shows several possible orbiters. Yes, for now, let's just talk until here, and thank you so much for watching my video, and thank you. Bye.